Kick this off. So I've got some slides and a bit of a demonstration that I will just make the requisite chicken sacrifice to make sure that that works okay. But what I'm going to show you today also dovetails into what we're showing at the booth in the rooms next door. So if you are interested in learning more, do check us out over there as well. So let me get this underway here. So I'm Mark. I look after product management here at Anjuna. Many years, in fact, in the hardware security space. Before Anjuna, I ran a cryptographic business unit at Amazon that was in the payment security space. And prior to that, also ran the data security business for Hewlett-Packard, which manufactured hardware security modules for payments. So I've been in this game for quite some time. And the reason I joined Anjuna was that for the very first time, all of the problems that I'd been trying to solve through those companies that I worked with in the past are much easier to solve with confidential computing, particularly if you have a software enabling layer that makes this powerful isolation capability simple and straightforward to use. And that's essentially what we're doing here. So what I'm going to talk about is how you've seen technical presentations today. Some people have dived deep on use cases. I think we're kind of on common ground with regards to the risks to cloud adoption and so on. But I'm going to tell this story through the lens of customers that we've been working with that are using this in live production environments that are at significant scale. And some of the problems that they're solving might seem fairly straightforward, but without confidential computing are almost impossible to solve. So let's go ahead. So if you're familiar, if you're not familiar with Anjuna, we're based here in the US. We've got roots in research at Stanford University. So quite a few of our team are here, as I mentioned. So pop by and do say hello. So I don't think I need to lecture you at all on the benefits of cloud. Many organizations use it today. You've got businesses that were born in the cloud, and that's fantastic. But fundamentally, when all of the benefits of the cloud are right there, staring in the face of many organizations, they can't fully embrace them. You've heard my peers, our CEO today, talk about the fact that in highly regulated industries, there's still hesitation. And indeed, while I was at Amazon, my job was to help unblock some of those workloads because of either lack of capability or because of the barrier related to risk and security. So there's tons and tons of benefits of getting into the cloud, which really can't be realized if regulated organizations through risk as well as, to some degree, paranoia. I mean, the statistics on this are very clear. Ayal, our CEO, presented in the main room about this. You know, if you look at most reports, particularly for regulated organizations, there's only a portion of workloads in the cloud, and that gets worse, particularly in financial services, which is what I'm going to talk about in a minute. Indeed, recent reports showed that around 15% of workloads, and those banks we talk to, this resonates very well. You know, if you talk to a Wall Street bank, in particular, some of the risk concerns are still there over cloud adoption, and certainly the apps that have gone into the cloud tend to be those that aren't heavily regulated and are not processing sensitive data. And of course, the number one barrier, and it's been this way for the last 15 years, is risk around data security and privacy. And with the increasingly complex regulations that have emerged over the last few years in data privacy, this has just remained at the number one problem overall. And I think it will continue to be that way. And I think confidential computing is going to chip away at this in particular. So here's the kind of the customer point of view. So, you know, obviously when you're in the data center, you own the racks, you own the equipment, you're running software, you own the people. In the cloud, you move to the shared responsibility model, which is a very natural way for cloud and customers to join at the hip, essentially, in terms of their overall responsibilities with regards to access to information systems and services. But ultimately, the liability still remains with the customer operating the data and the applications. And that is still the problem. And when you have this inherent risk that many organizations still are concerned about, which is the memory itself and data in use has not had strong protections, and in fact, we've almost ignored the problem or attempted to solve it with halfway solutions like data tokenization, encryption technologies, and so on. fundamentally, the risk is there. If you gain access to things like keys, secrets, code, models, and so on in memory, then of course you can gain access to a whole range of lateral things and move across the organization. And so that becomes that fundamental concern for many organizations. If they don't own the infrastructure, they really have no control over this. And of course, the kind of history is littered with the various breaches, many of which relate to software vulnerabilities, attacks to memory, attacks from insiders, attacks from those with inside knowledge of how clouds have worked, like in the one on the left, the very infamous Capital One breach. But the one I want to draw your attention to is the couple here on the right-hand side. In particular, late last year, a great software company that was doing everything right succumbed to an attack where the attacker essentially got access to memory, dumped running processes, and was able to access encryption keys that allowed decryption of credentials. And in this environment, the credentials spanned many, many organizations in this SaaS network. That impacted all of the customers effectively. And so these types of attacks that we've been talking about this morning, due to the vulnerabilities of clear data in memory, are here and a present danger, and indeed continue to be exploited. I would encourage you to read, there's an excellent report from CISA, which is the US body that provides guidance on cybersecurity to US government and to the private sector. They actually have a report on an attack that was done on a global organization where a red team penetrated the networks, got in, and in particular were focused on stealing data in memory. And one of the attack vectors was to steal a root key to a credentialing database. They did it through memory dumps, and therefore were able to then access many, many systems without detection for many, many days. And these types of organizations are already using vast numbers of software tools and traditional IT defense tools, and yet you had, in this case, luckily, a red team gaining access to what was ultimately highly sensitive information. So these attacks do exist. They're not theoretical in nature. And in fact, there was a report from Microsoft issued in 2019 that looked at all of the vulnerabilities over the last 12 years, and 70% originate with memory vulnerabilities and so on. And so while that's often, overloaded buffers, API exploitation leading to memory leakage, memory is a fundamentally weak thing that we use today that's got weak protections, I should say, until confidential computing came along. So, obviously, organizations today are using techniques like data at rest, data in transit. These are almost a given how you protect information today. In fact, you would never move a workload to the cloud without those types of controls. But fundamentally, the applications, the keys, the code, and in many cases, things like credentials, even to retrieve a key from a HSM, for example, are in memory and thus vulnerable. And so if you don't have memory protections, and you have attackers like those that I've just mentioned getting in, then all bets are off on data at rest and data in transit, because you can steal the keys and decrypt later. And that was what I illustrated. So the other thing that started to happen too is that while I can talk about this, and we as an organization, as the Confidential Computing Consortium, can espouse the benefits of protecting data in memory and so on, the regulators themselves are now starting to catch up to this. And in fact, over the last few years, we've started to see a tightening of what I'd call cloud outsourcing risk rules. So I'll give you an example of one of those in a second. But fundamentally, what they're about is making sure that there are guide rails in place so that enterprises around the world can adopt public cloud for all of the benefits that I talked about, but with sufficient guide rails so that systemic risk at a national level, for instance, a financial system or a telecommunication system, isn't compromised if there is a wholesale attack to that kind of environment. And so what it comes back to is resilience of these types of infrastructures. And what I'm seeing in particular is clauses that relate to data in memory protections or data in use protections. And this is something that's been missing from most regulations up to this point, with some exceptions in the privacy world where we talk about things like anonymization and de-identification, which is a different kind of approach. So in particular, in the UK, for instance, there is the regulator, the Prudential Regulatory Authority. This is the banking regulator for all financial companies. About a year and a half ago, they issued a regulation, very excitingly called, as you can see here, SS2/21, which I'm sure is just obviously what that is. But this is cloud outsourcing risk, and in particular, it mandates data in memory protection in addition to data at rest and data in use and so on. Data in transit. In the US, the SEC also has public comments out that actually just closed on the strengthening of their cybersecurity frameworks. And again, this tends to follow what we see in other jurisdictions like the UK or the European Banking Association and so on. How many here are familiar with a regulation called DORA? Regulations are really exciting stuff to read. There are pages and pages of minute details on how you should implement controls and things. But DORA stands for the Digital Operational Resilience Amendment Act. Curiously named, but inside it also has data in use clauses as well. And this is for the entire financial services banking system in Europe, for example. So we're seeing it expand. We've seen this in Australia after these massive breaches that happened last year with Optus and Medibank. The Australian regulator, which is almost equivalent to the UK, the APRA, is now revisiting its own standards with respect to cyber resilience as a result. We've also seen this extend to blockchain with EU MiCA, Singapore with its financial regulator, the MAS, the Monetary Authority of Singapore, with its tech guidance, which explicitly calls out data in use protection and confidential computing as an accepted control. And lastly, in the US, we also have NIST that is starting work on this, and there's a working group there that handles NIST 8320 with some of the members of the CCC as participants, and so we're starting to see this type of control framework that we've been talking about today in this event getting recognized not just around the world, but in some of the core regulatory bodies like NIST, for instance, which is core to many other regs. So if we double click a little bit on the Prudential Regulatory Authority SS2/21, I'm sure you're going to remember that when you go home today. But basically, what these typically revolve around is strengthening of the resilience in an outsourcing environment, and that includes cloud service providers. It's not your kind of classical outsourcing. It's when you're using outsourced IT, third-party hosting systems, cloud service providers, SaaS applications, and so on. And so this is a very broad regulation in terms of its scope and applicability. But you'll see here, I've highlighted the kind of the clauses in yellow. You've got the classic data in transit and so on, but again, data in memory is specifically called out. Now, to be clear, this doesn't automatically mean use confidential computing. There are other ways to protect data in memory and so on, and sometimes there are guardrails that will relate to the risk tolerance of the organization and the risks they're trying to protect or mitigate. But using confidential computing as a way to meet these controls is a very easy and simple way to do it when you have ubiquitous technology capability. So again, we have customers that we've helped solve this regulatory requirement for, amongst other risks, which I'll show you in a kind of a living case study in a second. So yeah, if you really want to get into this, I've got an invitation to participate in some of these activities at the end of this session. So obviously, confidential computing comes to the rescue here. It is essentially a technology which allows data in use protection, but also provides all of those integrity capabilities that are very, very important, not just to ensure the integrity of code, but also to prove to regulators that you are actually meeting them. And regulatory compliance to many organizations is, number one, difficult, but also very costly. And having a way to easily evidence compliance and prove that in hardware itself is actually incredibly valuable. And so we have ubiquitous capability from the chipsets, we have ubiquitous capability in the clouds, but really until we have the enabling capability that is simple and straightforward, That's effectively kind of where we come in. And so because of that diversity of chipset, because you need to be able to essentially run an application without any change whatsoever, no code changes, not refactoring. So for instance, if you're taking a third-party application and you want to run it in confidential computing, you may not have any capacity to make changes. If you've got a legacy application, you might not be able to bring back the developers to make changes to move that up into these kinds of environments. That's where we come in. And Anjuna, the easiest way to think about us is as a powerful virtualization layer that lets you run applications in confidential computing without any security trade-offs, but without application changes at all, and to do that at scale. So if you wanted to do this all yourself, and anybody in the room that, actually let me ask, is there anybody in the room here that's been coding to things like Intel SGX or AWS Nitro enclaves to date? Any actual practitioners here? Okay, good. What's your experience been like with, which platform are you using? And how would you rate the complexity? Up, down, easy? Yeah, and that's a common theme. I think Intel SGX is probably one of the more secure isolated environments, but as a consequence, it becomes also one of the most complex if you want to run applications in it. And this chart here shows you kind of all of the things that you have to do depending on the chipset. And again, it's not a fault of the chipset. There is complexity to this to get it right. And even when you start to look at things like, say, confidential VM, one of my peers for Photanix talked about this in a last conversation. It's about, you can put things in a VM, but you can still have risk of things in the VM talking to each other. So you really want to get this right from both a security, a transparency, performance, and orchestration capability. And essentially, that's kind of what we do. We collapse all of these very complex integrations into this enabling layer. So you can quite literally take an application, run it in confidential computing, in confidential computing of your choice, and to do that in seconds. And in fact, we work with customers who sometimes have been struggling with this for many years and have been able to solve the problems that took them 18 months to 2 years in about 15 minutes. And so that's kind of when I talk about that difference here, that green here actually is a massive time and investment difference, and again, without trade-offs. So what this looks like is essentially taking applications, and this is a stylized version of this, if you will, taking applications, taking a Kubernetes application or a straight binary, and just running it on the cloud of your choice with confidential computing. And all of the complexity is taken care of essentially in seconds. And so what this allows you to do is to take an application, instrument confidential computing into your CI/CD pipeline, and take advantage of those benefits that I talked about. And beyond that, it's also the operation and management of this too. When you think about starting an application or even starting a confidential VM, that gets you so far. But if you need to be able to have confidential configurations, confidential secrets, orchestrate that, handle that across multiple applications and services, then you also need that policy management piece as well to automate this. And again, without making a single line of code change to an application, because that can just be the difference between you getting an application up and running in confidential computing and not. So I'm going to talk about and walk through two specific use cases here. There are many ways to use confidential computing, as you've probably seen. Our big one is helping organizations who are blocked on getting data up into applications and data up into the cloud. So unblocking cloud transformation on highly regulated data sets where there are regulations requiring data and use protection, or where there's internal policies that mandate this. Of course, the cryptographic layers handling keys, sensitive code in cloud environments is also super important. That's a classic use case for confidential computing. But as we've seen, being able to run things like confidential AI models and so on to protect the data, the models, and to avoid data leakage out of those environments is also an emerging use case that we see more and more of. And then everybody here has talked about multi-party computation. If you think about it, if you're going to the cloud, there are two parties to start out with. You've you and the cloud. But we also work with organizations across multiple different businesses. So government, I'll show you a government case on this in a second. Okay, so let's dive in a little bit here on a couple of case studies. So the first one, Ayal alluded to this, and I'm actually going to walk you through kind of a visualization of what this looks like, is a very large European bank that essentially had this problem. Let me jump to the kind of the visualization of this. So this organization, like many banks, relied on classic mainframe infrastructure. Great. Indeed, it has memory protection. If you've been following ZOS platforms, some of the Z series have memory protection and so on. This is in the data center. And the actual system was operated on a kind of a transaction leasing basis as well. So every transaction has a cost associated with it. The problem was that during COVID, the bank was also closing down business channels on its branches. So actually, getting rid of physical branch infrastructure. And at the same time, with COVID, not many people going out, you had a massive spike on the digital channel uptake as well. And so what was actually happening was that the organization had already moved its digital front ends to the cloud, in this case AWS, but still had all of the transactions going back to the data center through that environment. And so as things nicely scaled out with Kubernetes on the front end systems, serving all of those millions of mobile users, essentially what was happening was that the mainframe itself wasn't able to scale. It's not elastic. And the option there was to add more CPUs, which is extremely expensive. So the desired state was to eliminate this problem, which manifested as latency for the end user. So imagine you're going to your bank on your mobile phone. You're attempting to get balances. You're attempting to look at what your credit card balance might be to make another payment or buy something. And if all of that is getting out of sync because of latency issues, or the rendering is going to take minutes, that's not a good experience. And so that's a risk of customer attrition at that point. So the actual problem fundamentally was that poor experience on the mobile channels. So what the bank had actually done, you'll see this little blue thing here. They'd created what was essentially a caching tier to offload some of the transactions from the mainframe, but this was still in the data center. And you had data in the clear here in this zone, which was acceptable to the bank. But as you move up into the cloud, you run into both the regulatory problems with the PRA in the UK and also the bank's interpretation of this, which was to guarantee that there is no personal data and no keys ever present in the clear when they're using a cloud platform. So here's how this worked. What they did is they started out by taking the records off the mainframe, encrypting them, in this case with a key management system in Amazon, and individually transferring those records up to a MongoDB caching tier that was in the AWS environment. With that, you've effectively got a copy of, in this case, about 45 million customer records up in the cloud. And so now they run this ODS tier, this caching tier, without any changes, migrated this up to the cloud, and used the Anjuna platform to essentially run this inside enclaves automatically. So now as the enclaves essentially start up, they can use attestation to retrieve keys from the KMS system. So number one, we've eliminated the credentials that have to be managed by the application here, which is a big security risk reduction. And secondly, now as transactions flow from the end users up through their mobile digital front ends, the data is never present in the clear. And so they solved this problem, and what it's given them is this elastic model. So now as more and more users consume the digital channels, the latency stays the same, the performance doesn't degrade, and the cost has been offset massively. So now the mainframe becomes just a data store at the end of the day, but the data, the ODS layer, is handling all of the transactions. And so there's cost savings here that are in the orders of multiple tens of millions of dollars per year just from that offload, as well as meeting strategic objectives of getting systems into the cloud on a more aggressive basis. And this was the first time this bank had moved a significant PII workload up into their cloud provider platform. So a really, really exciting and interesting project that ultimately came back from somebody possibly complaining about the performance of their mobile application. So that's one example of kind of cloud migration. The other one I want to kind of touch on here is actually a machine learning case that's to do with better citizen outcomes. Now, definitions of better citizen outcomes might differ when you think about this use case that I'm about to describe. So in this organization, the problem was this. In this particular city environment, they had a traffic automation system, so it's like a smart city environment, where pictures were taken of vehicles and video feeds were taken of vehicles as they enter and exit roads and motorways and so on. And they use what's called average speed detection to issue tickets. I don't know if you've ever driven on one of those roads with average speed detection where you have to stay exactly at 55 miles an hour or whatever it is. It's really frustrating. But notwithstanding, they had an environment that was not scaling well to handle the kind of the volume of incidents. So what they wanted to do was to take what was their own AI models, their kind of own infrastructure that was running in a data center that couldn't scale and move that to a cloud environment so that they could issue tickets more efficiently to citizens. So you get a better experience, but you're getting more speeding tickets. So that's why I say this may not be the best way of thinking about good citizen experiences from my personal perspective. But this is what this looked like. So the before case was essentially that they had their proprietary AI models for image recognition and detection in the data center. This wasn't scaling well. The customer notifications were taking a long time and sometimes not the most accurate as well. Plus there's also privacy and there's emerging AI ethical rules on handling sensitive data. And in this particular case, that was a significant requirement. So the way that this was actually deployed was that they had their own architecture, their own applications, their own models that they had trained on the data feed, so they had a nice accurate way to handle that. But they were able to separate the GPU processing from the regular processing, but run the personal and sensitive data operations inside enclaves, and to do this automatically. And so essentially now you can go from the camera feed end to end up to enclave systems and get real-time feeds to notify citizens. And they've overcome a lot of those inelastic challenges that they had in the data center and not having to keep racks of GPUs and CPUs available the whole time, which they had in the high-cost data center model. So if you want to see this in action, you can actually see it on our booth. We've got a demo that shows exactly this. You can come by and have a look at it. But in essence, I want to wrap at this point. The fact is that confidential computing can solve a whole gamut of different types of problems. Some of them might seem mundane and so on, like moving to the cloud, but without this technology, organizations will still remain to be blocked. And if we don't have this capability enabled today, those statistics that I put up are still going to be exactly the same in 2 or 3 years' time, and that will be counter to the mission of most enterprises that needs to get to the cloud for elasticity, for scale, and to embrace new markets and so on. And that's where Anjuna is this enabling layer to make this possible, along with the technologies that I've described. Lastly, before I wrap, we're working closely with an organization that's part of related to the CCC. It's the Cloud Security Alliance. It's a confidential computing working group that's actually working on influencing regulators in this space as well to create more awareness. And so if you'd like to participate in that, come and let me know. There's myself, Mark Novak from JP Morgan, and Alec Fernandez from Microsoft involved here on this as well. So thank you for your time. I think I'm down to like the last 15 seconds. Okay.
Great, thank you. Do we have questions?
I think everyone needs coffee or something now. Cool.
Well, let's thank our speaker again. Thank you.